Hello. So, this isn't the actual start of the stream yet, it's just me getting working on. So, there we go. Let's just turn the music down, might be a better idea. And get rid of this weird public domain stuff by Kevin MacLeod. There we go. Alright, so how's everyone doing today? Good? Good. The stream won't start for another about 5 minutes, so I'm a bit later than I said. That's why I've added the ish at the end. So yeah. I was actually doing some last minute. You're doing... Yes, you're doing Sleepy World and Mikhail. Yes, I've just done some last minute things to the compiler, which I hope doesn't break. Oh, that's always great, isn't it? Oh well. Mainly it's just me speeding up everything, so it goes speedy, very fast. Right. Shall we get started? Yes. This might be a good time to start, I think. So, hello and welcome to today's compiler stream. This is the second one that I've done for the demonstration of my new programming language I've been developing. In the previous demo that I showed off and talking demo, I explained why I'm creating a language and also kind of the base of what the language kind of looks like and how it's going to behave. And today I'm kind of adding to that and showing all the other stuff I'm going to do. So, to kind of today's theme, if you look at the Twitch title and anything, is composition and refactorability. And they're kind of some of the key things that I'm going to be talking today about. And why is the short answer. And some of the ways I'm going to try and solve that. So, let's get rid of Milton and start getting this up. That F11, and that's there. And oops, I've got a bit of screen burning. Oh well. Okay, hopefully that's just, yeah. So, this is the demo today, and there's some other things I've got to talk about. So let's just start with our main procedure, which is the entry point of our program. Very nice, very little simple. Now, some forenotes I'm going to say is that I've now made semicolons optional. This is mainly not because I don't mind typing them. In fact, I keep typing them accidentally and think I have to remove them. So, the reason why I've kind of removed them is, again, talking about this refactorability and also being consistent with the syntax in places when I wasn't using them. So I was like, I wasn't using them in type declarations, I wasn't using them for procedure declarations, and it was just kind of like, there's some weird odd cases here, and I thought, why not just remove them entirely and follow some very, very simple rules for removing semicolons. And the way are is, the next token, so this as a token, that's a symbol as a token, whatever token, it's like a little smallest like measurable block. If it's not on the same line, so it's on the next line or line below, then you don't have to write semicolon. If the next token is on the same line but it's a closing brace, then you don't need to write a semicolon. Otherwise, you need a semicolon. So they're the rules. Very simple. The only exceptions to these are in for loops, where you've got to separate the initial, like the post, and the initial condition and the post. If statements where you've got the initial and the condition, and match what I'll get onto later. So like here's like an if statement, so initialization and then the condition. So there's condition. Again with for, initialization, condition, and post. That's all it is. Now my question is, do I just keep rid of the semicolons, or shall I go back to adding my old rule, which is a bit odd, but oh well, doesn't matter. So, the next thing I forgot to do, this was in the previous demo, I've got to show off some other things, was one is thread local storage, is built into language, it's up here as well. There is one main use for this where it's very important, where I've got to have it, and that's me coming on down further on when it's in new built-in section here. And explain why I need thread local storage kind of built in. But it's built into language, you just say this is now thread local storage, global variable, whatever. And then there's now foreign system libraries as well. So if I go into Win32, I say foreign system library user32. So this is kind of like Pragma in like MSVC or something like that, where you just say, here's the thing I want to install, well, here's the thing I want to link with, do that. And I can just do it in here. And this is my Win32 library, by the way. It's my mini one. Let's go back. So let's start off with the first section. The very small one is struct compound literals. Or that's how I do it, yeah? So here's a struct definition here, and it's just a thing. So it's got an ID, X, and name. And you notice no semicolons anywhere. Yeah, whatever. So let's just define it. Thing, and then it says ID equals 1. Great, that's how we initialize it. But sometimes you want to initialize it as on its own. So this is my initialization syntax for structures. And also vectors and arrays and such like that. So you have the type on the left, and then you have some curly braces to open them up. So, and then you've got the fields inside. If you omit none, it means it initializes to 0. If you put all the fields in, that means they initialize all the fields in. Yes, makes a bit of sense. However, you're not allowed to not have all the fields. So if I compile this, this is compiled, that's all done, that all works. Yeah. If I put in that error, it'll say, here you go, too few vowels in struct literal, expected 3, got 2. So, and here's the line and the column you're in. So it said line 50, column 29, 19, wherever that is. Yeah, good. Now, the other thing I quite like as well is, if I've got that, why can't I just have random access and name the argument? So I can just say name, pass that in there, X plus pass that in, and again, it works in any order as well. So hello for everyone else who's just joining on the stream. So that's quite nice to have, and it's usually very useful for me. And again, with the name things, you don't have to have them all of them either. You just have to have 1 or 2. You can have none, in fact, that can be annoying. So let's go on to struct. Let's struct literals, that's dead easy. Let's go into the enumerations now, which are very useful. So an enum in C or C++, usually the values of the enum are brought into the parent namespace, is what they usually are. In mine, it's more classed to the like C++11's enum class, so it's within here. So to access the variables within an enum, you have to go the type dot the name of the enum. And enums have the same rules as like in C and C++. They start from 0 and they count up. So here's apples equal to 0, bananas equal to 1, pears equal to 2. It's fine. Now enums are type safe. Now this means you do not have automatic conversion between the actual number value, which is 1 in this case for banana, and an int, which is underlying value. So if I do that, there's a compiler error. It says cannot assign fruit banana of type fruit, and there's also redeclaration of G. So I'll just call this G112. There you go, get rid of the error. So, but you can do a cast. So you do like, here's a G int, and it's going to be as an int. Now, however, I have allowed that enums can be used in index values. So if I had like, there's an array here, and I wrote, oops, fruit banana here, that would be perfectly allowed. There's nothing wrong with that, because in index values, I allow any integer allowed, even if that integer is an enum. This is just because I usually use enums as integer indexes, and I don't want to have to keep casting it to an int. So there's one bit rule. When you get down to it, you can also specify the size, underlying size. So this is be an underlying int, which is also the default. You could say it's a U8 as well. And also, you can also specify the values of it. But so if you specify apple to be 1, the next one will auto increment to 2. Then I'm saying pear's going to be 5, and then tomato is going to be 6. That's good. Now, one question I have, which is a minor question, should I have to get rid of type? Like, I know this is going to be a type declaration after the double colon, so do I assume it's going to be a type, or should I explicit and be consistent everywhere? It's a minor question to wonder about, but yeah, there's enums, very simple things. Let's go on to the next clever thing I call, and this is kind of useful, and some of you may be able to guess why I've added this now, and what's going to be in the next demo, if I finish it. Is I've got variadic procedures, if that's how you pronounce it. Is it variodic? Variadic? I have no idea. And so what you do is these are type safe. Now in C, if you want a variadic procedure like printf or something, it kind of relies on like a hack with the stack. So it kind of says, hey, it doesn't know what you've passed. You have to kind of figure it out. And it's kind of a bit dodgy. So with mine, I'm being extremely type safe, and I'm only saying, hey, here's the arguments, and I'm putting a dot saying, hey, it's going to be multiple here, and then int. So that's kind of how it looks, and then you can get the length of how many arguments are in here, and you can just access it as if it was just like an array or slice or something like that, and it works. So let's just pass no arguments to show that you can do that. And that's the first line, there's nothing there. Second line, we can pass 1 and we get 1. And if we pass 3 arguments, we get 1, 2, and 3, which is exactly what we see. Enums cannot be another type yet, and I'm thinking about maybe changing that, but I don't really need them to be. And you can have them as like a char or rune, because that is just an integer type, by the way. So that doesn't matter. But strings, I don't know. I'm thinking of something else, and that's what's going to be probably in the next demo, so don't worry about that. So that's just some basic things. And to prove it, you don't just have to be that. You can put a prefix on things, and look, here we got A, got nothing. B, you got 1. C, you got 1, 2, and 3 for floats as well. So floats work. So internally, instead of doing the C version where they just keep pushing them onto the stack and keep them onto the top of the stack, I do the same thing, but instead of that, I only allow all the same type, and I send extra information across. Cast enum to strings is going to be next demo's feature. Shh, I'm not hiding things, that's going to be in a little while. Yeah, I don't want to spoil things. Spoilers. But yeah, so the internals of this is actually a slice. So the slice holds a pointer to the data, the length, and the capacity. So if you pass a variable thing, the capacity is going to be equal to length. So that's quite nice to use. So you just pass all the arguments in. So this is kind of the first step to get a print procedure that works, but I don't have an any type yet, and this requires a few things such as introspection. And that's one thing I have to kind of finish doing, and I've kind of started to work on it, but it's not in the language yet, and I didn't want to broadcast either. And again, I haven't added the feature yet either, passing a slice and expanding all its elements into it. So that's not hard to do, but it would be a nice thing to do. So I could pass a slice in, say, hey, expand this out for me, and it will do that, whatever. Okay. I don't understand. I'll leave questions to the end. Well, you can leave some questions now. So let's talk about the new built-ins I've got. So the first one, of course, is this is kind of like C++y. Is new. Is again, it creates a new variable, and this allocates a new int for you, and this is going to be of type pointer to int. So if I wrote that, pointer to int, it will compile, and that's perfectly correct. So that's fine. I can also allocate a new slice, so I can give the base type and then its length, or even a base length and a capacity, so you can keep appending to it. Now I've also added this delete procedure as well, this built-in procedure called delete. So it will delete either integers or slices, and it's overloaded here, and it will just do it. Now the thing to note here, this is why I kind of like it, is these do not just use the default allocator. These are whatever the current context allocator is. So to prove what that I mean by that is here's what the current context is. This is an implicit variable using thread local storage. So if I go into the runtime and then go to context, here's all the stuff here. It's a bit dodgy at the moment. It's something I've just been adding in. So you have some allocators that you can define. You've got context with some of the data in here, and you've got an allocator, and you've got the context thing, which is thread local. So you don't have thread collisions. So there's what the context is. And new and delete and all the other allocating functions like alloc and alloc-align and freeall, there's a few more, and resize, all use the underlying context allocator. And if it's null, it will just revert to the default. So I can set what the allocator I want it to be, and now it's using that allocator. So that's great in my opinion, because I don't think there's many languages apart from JI, where I nicked the idea from personally, is that actually allows me to actually change how I allocate things, not just use the default allocator. And I think this is great, and this solves a lot of the problems, because in my compiler alone I'm using, oh God, how many different, about 2 or 3 different allocators, like arenas, heap, and stack, and a scratch allocators and such. So it's quite useful. So now let's keep going on down some of the built-ins. So we've got Typeoff. Now Typeoff is type of val here. It just gets the type of what the expression is. That's it. It's done. Now, I've called it type of val rather than type of, because I've got another name convention, like I've got size of, a line of, and offset of. These all take in types, and offset of also takes in the field member of whichever structure it is. Size of val, line of val, offset of val, and type of val take off a value or an expression. So this is quite, again, useful to use. And again, just consistency. I might change it so they all become size ofs and get rid of the val bit, and they kind of overload the thing, but I don't know. I've had so many problems with macros, at least, where I've had problems with size of when I wanted the value rather than the type, and it's all confused. But again, I don't know. It's only a minor point. It's like a 5-minute change. So now let's go on to the next thing, which I quite enjoy. So now it is asserts. So the first one is compile time assert. So here's a constant called con for condition, which is true. Now if I said this was false, so assert, it will say compile time assertion here, and it'll do it. And it's just called assert. However, this same thing also works for runtime. It's the same name. So if I have a runtime assert and I call it true, I'll go, so true doesn't work. Let's do this one. It says here. Now I've got a crash. That's great. It says runtime assertion here. That's what line and column and the file. Perfect. Don't mind the weird thing here is a race condition within Sublime Text, where the error output and the default output kind of just go in random orders. Yay. But there, it doesn't matter. So there you go. That's quite easy. So now let's go on to some of the pointer built-in stuff that I've had to add. Now I've now added pointer offset. This is the same as like if I wrote in C, x plus 100. This pointer sub, this would be the same as this in C. Slice pointer, there's no equivalent because there are no slices, but that's kind of what it is. Now I've added these in because I have gotten rid of the pointer arithmetic, pointer indexing, and pointer slicing. So pointer slicing means here, make slice out of this pointer. Pointer subtracting tells me how many units away it is, and this is a kind of equivalent in C and C++ as in C++ you'd write it as like this. So you'd say U8 cast is y minus U8 cast of x minus the size of whatever the underlying value of x is. That's what it would be, which is not what C++ does, actually. You'll see. In C or C++, when you do subtractions of pointers, it assumes they are both aligned to one another, which is not always the case. So you have to do this anyway to get what you need. So stupid C++ spec, or C spec at least. So why have I got rid of pointer arithmetic and pointer slicing and all that lot? And the main reason is, when I have a structure, like so, and I have, like, we'll say this x refers to a structure, I don't have to dereference to get the next value. I can just automatically dereference. So I wanted the same kind of semantics with arrays and slices, so it automatically dereferences. So here's an array of ints, 16 ints, get the first value, set it to 1. Now this is a pointer to this thing here, so this would be the same as if I wrote, oops, can't even type today. It is late at night. I can never type anyway, that's the short answer for that really. That would be the same as that, but I'm just inferring the type, that's all it is. And see, look, I'm just accessing this. This would be exactly the same as if I wrote that caret there. So P, take B, get the pointer from it, sorry, the pointer to it, and then dereference it. But yeah, it's just automatic dereference. And I'm not sure if I should add it back in, because just to save the cost of inconsistency, but it helps in some places. I don't know, it's one of those kind of things. So now let's go to the last set, which are very useful, and I find I need them a lot sometimes, which is kind of min, max, and absolute. That's about it. Now min and max will work on anything that can be compared, so integers, floats, strings as well. So you can have the min and max of a string. Doesn't matter. Now these are done at runtime, so if you print these out, the print line should be, the minimum should be -1, there we go. Maximum should be 2, and the absolute value of this value A should be 1, so that's what we get here at the bottom. Perfect. Now they work at compile time as well, so if you've got compile time expressions, which are the : expressions, they'll work as well. So for print C, I get -1, 2, and 1. So it's the same code. Works. Great. So now let's get on to the first fancy feature, which I actually had to implement before I could add some of the others. So in some languages, they have switch statements, like C and C++, and so many other C-style languages have switch statements. I've gone calling it match because I think, why would you call it switch in the first place? What does that actually mean? It's a bit of a weird word. So I've called it match. But it also does a few other things. So the first thing is, here's a match statement. It looks just like C. So here's my expression. I've got cases, 1, 2, 3, whatever. Cases in the default one. Now, all cases have to be constant expression for this type of match statement. Now you'll notice, break by default. Now in C++, it would fall through by default, and I think this is one of the worst design decisions in C, because you never, very, very rarely ever want it to break by default. So I've just added it. The second thing is, in C, the other thing switch statements don't do is they don't create a new scope for each case. The whole scope is from the curly braces. So if you declare something in this case, it's also this scope is also accessible in this one. So that's a bit crazy. And you can see there's the 2 factorial, or 2 exclamation mark here. And you can also do an explicit break if you need to break on early on. That's fine as well. Multiple cases, you don't have to rely upon the fall through anymore. You can just do a list of them. So I could do 1, 2, 4, 7, 12, whatever, and it will do all of them. So that's kind of what it is. And that'll do work there. And if I just change it so I change from 1, should get 1 there. If I change it to 2, you should get a 2 exclamation mark there, yeah. Change it to, actually, you know what, to make it easy to read, I'm just going to comment out all the rest. So it's only working on match statement, there we go. So it does all works on the others here, great. So that's all that, and just to prove it again, go to 4, 3 or 4, let's go to 5. Now if I print 5, you can do an explicit fall through if you want that behavior as well. So if you're doing like some duff device or something like that where you want to fall through, you can do that. Works perfectly fine. Now, switch statements don't have to be integers. They can also be floats. So these are floating point numbers which are constant. Tau is 6.28, whatever. And you've got 3.5. You can see there's 1.5 there. Now if I change this to, let's say 2, it works. Let's say I change it to math tau. And guess what? I get tau. It's great. And also, Unicode all works. So that's great. And it all works perfectly fine. The thing is, also I'm also doing strings as well, so you can also do strings. Because anything that's like compile time expressions, you can do that. So I've got quite a, mildly good compile time execution in my language, so it's quite nice. I'm just going to get myself a drink. Wait, I've got some, pop in a bottle here for myself. These streams aren't that formal. Anyway, even if they were formal, still probably have a drink. Oh, the fizz. All that fizz. So there you go. There's the basic stuff. Okay? That's just the basic stuff. So now let's get to the fancy one, which I still haven't finished all the features of it yet, but these are going to be my kind of like my match patterning system. So if you remove the expression in the match statement, you can treat it as kind of if it was like a list of if statements. So there's a case of a equals 1. So here's a, 53. If it was equal to 1, it goes to 1. Equals 2, it goes to 2. If it matches this case or this case, you can do that and do this and do that, whatever. It follows all these cases. And the thing about that, this is kind of identical if I was writing as an if statement. The difference that comes from this, as if you may not know, is that I can fall through on this, I can break on this, I can do whatever. In an if statement, there's many times I want to just break early from an if statement, and I can't. But I can with this, like a match statement. I can break, I fall through. In an if statement, it's impossible to fall through. Breaking, you'd have to use something like a goto, but yeah, it doesn't matter. So I think this is probably much better, and also it's a lot easier to read and write, in my opinion, because I just keep going doing that, rather than have to do big old nests, and it's temperamental as well. It's not always easy to write. So There are other plans for this, for having like pattern matching and stuff, so I can do like, is it within this range or is it other stuff? But yeah. So that's kind of what it is. So now let's keep going a little bit further down, and let's go to the fancy thing today. Again, nicking some ideas from JI, but slightly other things as well, so you'll see a bit later. I've just brought these into the global namespace so I can use them elsewhere. Let's talk about how we do things in C to begin with. So in C, if I had a structure called thing, and I had elements x and name, to get the values I just point x. So the thing about namespacing in this language is if I declare this type here and declare another type of the same name, this one overshadows that one. So this thing here is actually using the closest one it can get. Okay? So this is the thing, this thing here defined by B is test. If I try to write x, it'll say B thing has no field x. That's what it says. Makes sense? So it's overshadowing it. So there's some very simple namespacing rules of going on. So it's just scope rules. It's the same with procedures and variables and all that lot. It's like lambda calculus rules, whatever. So now let's go to one a little bit more complicated thing. So we've got nestings of types and variables with normal scopes. We can nest types within types and constants within types as well. So here's an entity type. So you've got like the GUID of the type, another nested structure with another type inside of it. We've got a constant within the type, and then all the other variables inside there. So, whoops. So if you want to access these variables, you can access the type, which is like entity GUID equals entity constant. You just put a dot in there, so to access the namespace. So this is all what it is pretty much. Now, if I want to access the nested variable, I go on the myint, I go entity.nested.myint to get that type. So now I is of that type. Yeah? Okay. So now let's say, okay, this gets a bit annoying, and you don't want to go to boost levels of annoyingness to get all this namespace game. And it's, so you may think, I'm using all these variables all the time, like I know I'm going to be using this scope. Can I just use them without, and the thing is, yeah, so what I'm saying is using. So now if I write using entity, this brings all of the constant types, the types and constants, into this now scope here, in this scope. So I can access GUID and constant as if they were there. And I could apply it to anything that's also been exported, like nested, which was in here originally, and now get myint. And just to prove that, if I write nested afterwards, it'll say undeclared type or identifier myint. So it's saying, hey, I can't find this. But then it does find it there. So it's great, in my opinion. So this saves a little problem. Well, the thing is, you could also say, actually, I don't want to export all these. I just want to export the things in nested. So you could just do entity.nested. That works. And you can all the GUID and the constant explicitly. Simple. So you think, okay, we apply this to types. Can we apply this to the actual elements, the fields within the type? And the answer is, yes, you can. So if I have entity E here, and I'm saying using E, now I'm getting the elements from GUID and name in here. So just first of all, I need to go, let's go back to the demo and just put that in there. I can now get the elements from here. So the members of this literal variable here on the stack get brought their namespace out, in a sense. So to prove it is, here's like the first thing, 784, let's just give it another number like that, and thing we're going to call it Bob. Just to prove it's there, there you go. So we can also access it manually, .e.guid, so it's making sure it's referring to the same type, and e.name, it's Bob. Works. And we can be a bit more terse, we can put using on the same line as the variable declaration, so we don't have to worry. So see there, it's the same thing. That's great. So now you're thinking, okay, what else can we do with using? Why don't we just apply it to the actual member variables in the structure? So taking kind of namespacing to the logical extreme. So now I'm saying, okay, I've got this vector 3, which has x, y, and z, and I want to bring those values into this entity's namespace. Because a lot of the time, I just want to say, hey, I want to change the position x of the entity. And that's great. And there's also another nested point here. So I'm using a pointer. So nested has the I value. So this is the same as if I was writing e.nested, dereference it, and then get the element That's what that is. But because in my language, dereference is automatic, and now I've also specified that nesting within the structure is used, you don't have to write it. That's what it's saying. And that's one thing I kind of like doing. And this is great for refactorability, and also great for composition as well, like expressing how you want to express data. This is one problem in C and C++. It's not very easy to do. In C++, you would have to like do inheritance or something like that to get these into the namespace, but you don't have the data layout or sometimes, and it's a pain. So let's go a little bit further. So that's kind of one thing I love already, and I already found hundreds of uses. I would find hundreds of uses for anyway. So good. So let's think, okay, we're taking this into one namespace. What can we actually do with that other than just this simple short syntax? Like, you could be saying, yeah, I could do that in C++ already with references, and on the constructors, satisfy not the values like that. I'm like, okay, fine, whatever. Let's just bring it down. So here's an entity type, and it's just got a position vector 3. So I'm going to have 4 different functions here, or procedures, or whatever you call them, and they all pretty much do the same thing. So this one's explicit. You pass a pointer to an entity, and then it prints the positions here of x position, y position, and entity position here. It's very explicit. Entity.position.x. This one here says, okay, now we're going to say using the entity. So we're actually using a live pointer, and we're going to bring it in. And then we've got print position.x, position.y, and position.z. We can apply, again, syntax sugar, put the using in the actual parameter field here. And again, we can just say using and bring that into its namespace. So we can just refer to everything as x, y, and z. Now, you can see this all works the same code, and it's all the same variables, and they all work. Now, this is very similar to how C++ is this works, or in many languages you've got self or whatever. But in those languages, that variable's special. And it's a bit weird, like, why is that special? Why can't I do that with any other variable? And why is that the only one that's implicit? And I've just kind of said, look, we're getting rid of that idea. We're actually saying, no, nothing's kind of special. You can set any of these to be that special variable if you want. And in many contexts, you're saying, I know I'm talking about an entity. I want these fields. I don't want to have to keep writing the value. So it's great. And also C++ is only available in methods. It's not available in functions, like standalone functions. That's great. So that's the basic subtyping things going on here now, isn't it? Sorry about that. So let's get namespacing and go on to the next subject. So yeah, that compiles. Let's go on to subtyping. So subtyping is usually one way of expressing kind of like a hierarchical data structure usually, or not hierarchical, but like maybe whatever. I can't think, I'm not doing technical terms here, but let's carry on. So the first one is, in C, you would do this. So I have base entity like class or whatever you think, and then you'd have an entity here as well, and you'd go entity.position, and then that would be it. Now you could write, using here, this is again the C way of doing it. Now we've already learned that we can apply using to everything, so why not do that? So let's just make it a bit simpler, apply using here. So now I can access all the variables here. So this is kind of like C++'s inheritance and like inverted commas subtyping or subclassing method. But we haven't have to have like had any mention of like vtables or methods or anything like that. It's just data, just data. So one thing that can refactorability in it as well is that now we can just say, hey, this is actually a subtype of an entity. So if a procedure requires an entity, notice this is not pointed, this is actually by value, I can pass f.entity or just f because it's using entity. So I've now got a form of subtype polymorphism into the language. I think that's the technical term. I have to research a lot of this. Again, I am not a programming language theorist or anything like that. I'm not, it's just I'm being quite pragmatic. I'm not trying to please a programming theorist's wet dream or anything like that, but yeah, you know, I'm learning the terminology as I go along. So yes, let's get on to the next thing. Let's go on to a more kind of efficient C++ way, which you couldn't do in C++, in fact. So the first thing is, you don't have to have that using as the first member, as we already learned. But And also now I'm going to say that the underlying data is actually a pointer. So let's say you got f for frog. Now entity I'm going to allocate to be a new, and then use set up the position for it. Great. So now the underlying data may be an entity. So you may think this might be a more efficient way of doing it. You may have found out. You may have different parts of your code which is hot or cold or whatever. And I'll explain this in just the next block to explain. Now, so we've got print position. So using entity of pointer, and it works. So the first one is just to get it explicit. f.entity. Great, now that's fine, this is expected. We could also get the pointer to f, so it goes pointer to f, then it looks for the entity, oh no, this is also a pointer. Or we could just write f, because also one of the fields is a pointer. Now, you may be asking, why have I let both? Well, the reason is, you may be thinking, oh, down the line, I don't want this as a pointer anymore, I just want to do that. And you don't want the code to break anymore, and just get rid of that for a second. You don't want the code to break as much, and it shouldn't be that hard to fix. Oops, there's a compiler bug. That's what I did earlier, and it didn't work. Shh. That's what I added. No one saw that. I'll fix that in a minute. But yeah, that's what kind of one thing that goes on, and it's just trying to make everything easier. And it's just like sometimes you may want to do pointer to or a pointer f, and it doesn't matter. So that should all work. I need to fix that bug. Don't worry, that's fine. It's only a minor bug. So let's go for a more efficient subtyping. Now, this you may be allocating instead of with new every time, you're allocating from an array. So you can have. Let's just make this a bit bigger to read. You've got. Well, this is gone with the next line. It's just cut it here for me because great, that's what I wanted. So you pass in, here's a procedure, and you get next entity, pass in a slice and the entity count, because I don't have closures, and I will probably never have closures, because they're too complicated. Not just to implement, but even to like rationalize about, like they require garbage collection. To use them, if you're going to use them properly, in a sense. So you could set up the entity data here, and all the like base thing of the next entity, go here, whatever. And then it still works. So this is 346, there you go, 346. So now I've been able to go kind of up the stack, so I've gone from the derived class up to the base class. Can I go the other way around? So can I go from the base class to the derived class, so downcast? Now I added this on stream the other day, and it was kind of like Alan, who's the creator of Fullcoder, very good text editor. Go check it out if you want some to replace Emacs. He was kind of suggesting this idea. I thought, yeah, I'll do it. Why not? So here's downcasting idea. Here's an entity. Here's my frog that's using that entity, and I'm setting a frog. Here's the jump height, setting that whatever. Now I'm going to get the pointer to the entity here, which is in classing as z. Now that's just a base class, so I've lost all the information about it being a frog. So I'm going to say no, I'm going to downcast to a pointer of frog. And now if I get the frog jump height, it should be the exact same thing. So it's 564. Let's just change that to be 123. Yep, that still works. Oops. Whatever. Now, downcast is very unsafe because it was a very cheap hack that I've done. And there's no check at runtime or compile time to see if this actually is valid. In C++, there's like a dynamic cast, I think, and that does some runtime checking, and it's not very useful at times. Well, it's useful, but it's like, should you really get in this type of situation? So my question is kind of, do I remove it? Because you could just say, hey, what's the offset here? And then go how many bytes back to get to the thing. It's a bit more verbose, but it's I think it's a bit more clearer. But yeah, that's fine. And the second thing is multiple inheritance. So you could use two things, and you could apply these different functions that have the different base classes. It doesn't solve the multiple inheritance problem, which is like the triangle problem, but it kind of does in the fact that I don't have methods, so you doesn't say which one to use. And also, if you do inherit from multiple things, and there is a namespace collision, the compiler would get it straight away and say, hey, you cannot do this. An overlapping collision. So let's get the next thing on track. Let's go from subtyping to tagged unions. This is the thing that I prefer much to do. So I don't really usually like the subtyping method for like hierarchical types. What I prefer is something called a tagged union. So in C, the way you have to do a tagged union looks kind of like this. You've got an enum, which is kind of the kind here. So this is whatever. Got it. First 0 is invalid, then frog, then giraffe, and helicopter. And then you have like a union in C, which you make anonymous. So in C it would kind of look like that, but in my language I have to say explicit using, so it's named and also anonymous. And then you'd have the fields in here, so the frog, giraffe, and helicopter. And then to access all of these things, you'd have to go, okay, entity kind, you have to set it explicitly. Then you'd say the frog, then the drum pipe to get all that. Now, this is a pain in the arse in C, and I'll show some code later explaining why I say it's a pain, because it's really not good to write. The first problem with C is you cannot get the type, unless you write all these structures outside to get the types, and then you have to write them in. So it's like more verbose to write, and it's a bit more, oh great, that's not good. So, but in C++ there's auto, so you can get that. That's better, but it's still not great. In my language, you could say, hey, type a val. That'd be a bit better, but it's still, again, verbose. Again, and also the other thing is this is very unsafe. Even if this frog was, this entity is tagged as a frog, I could still access it as if it was a helicopter. And I use macros a lot to alleviate this problem, but again, it's not a solution. I'll show an example. This is in the parser, and this is my tagged union of all of my nodes. This is how I do all the nodes, and look, I use macros to alleviate all of this. So this generates all the code that I need as well. I even have some metaprogramming tools, but for this compiler, I've not used them for numerous reasons. Like I want this to compile without the tools. So yeah, this is what I've had to do. And look, I'm still going, by the way. Oh, that's a lot of code. And there we go. And then look, here's the generation for us. It's this little X macro thing. So yeah, it's not brilliant, but it works. So, whoops, that was not the code I want. So let's go back to the demo. So let's say we actually built this into a language. This is with a proper thing. So here's a bit of smaller code. And you know what? That's all I had to write. I didn't have to write all those macro crap. There it is. Got an entity. Here's the frog, the giraffe, and the helicopter tag. And we're just going to say using entity. Now the thing is, these are this is slightly weird. These are actually new types. So I can refer to the frog and specify all its elements and assign it to be a type frog. But the other thing I can do is these can also implicitly cast to this entity. So now this actually has now become a tagged entity inside. And I can also explicitly cat with an as as well to do it as well. But then that means, hey, I've now got a tagged union, and this entity knows that this is of a type frog, and I can't access the giraffe or the helicopter elements either. So this is not allowed either, because there is no field named frog. And it says, what? What do you mean? The reasoning for that is I don't want you to access members that way through tagged unions, or a union, whatever I'm going to call them, whatever. Discriminated unions, whatever. I want you to access them through another construct. But just to prove it works, here's like an entity of E, F, G, and H. F is now set to be a frog, G is a giraffe, and H is a helicopter. That's fine. Again, these are all still entities. Okay, so here's my new special match statement. It's a match type statement. Now, at the moment, I'm not sure about syntax, so I'm saying, hey, here's a variable x, which you're going to be using inside here, and it's going to be of a pointer to the entity. Now, this is because this now x is now a pointer to one of these subtypes inside. So if f is a frog in this case, so you get frog, and to prove it's that value, I write it should be set to 12 originally, and I'm going to set it to 3, and then it prints out 3. So great, it's just changed it, whatever. If it's going to be a giraffe, let's put that to G. And now see it says giraffe, and great, that says we change it to a helicopter. Okay, helicopter says rufflecopter. Yeah, rufflecopter. Change that to the null entity, it says invalid entity, so it's none of them. It's none of the ones you specified. In fact, if I got even rid of helicopter and put helicopter in there, it'll say invalid entity. I haven't taken into account that case. So that's good. Now, I'm questioning is, should I allow for non-pointer versions, which takes a copy of it, and then you'd have to store it again like this to rechange it if you want to do so. It's more like a functional style. Or shall I leave it as a pointer? I don't know. Or pass it by value, but it still gets the pointer to the underlying data. It's one of those things, like, I want to see which is the least surprise, in a sense. which is the least surprising. At the moment, this is the least surprising method in my opinion, but whatever. So now, the way a struct is laid out, I can also, if you want to be unsafe, you can cast that pointer to the actual underlying types pointer. So you can see this still works. It's a frog. So if I write that now, it should become 3. So it's actually cast. So the internals are actually a tagged union, looks like this. It's actually an array of whatever the biggest size is of bytes for the data, and then it's a tag index at the end. Now the reason I've done that is 1, so you can do this, so you can just cast it if you want to do it, and 2, to make sure you've got alignment, so all the elements in the struct are properly aligned. If you have a tag at the beginning, it kind of loses its alignment problems, and it just becomes a little bit confusing. So that's how I've kind of structured it, and I think that's probably the best idea. So why do I think, so I'm just looking at my notes here, why do I think that I prefer tagged unions to the standard subclassing or the inheritance model? And the main reasoning is this. I allocate a bunch of entities and then just allocate to them. And look, I didn't have to do any dynamic allocation with new or anything like that, what you would have to do with inheritance or subclassing or whatever. I just standard in that. So I can allocate them on the stack, I can allocate them on the heap, I can pre-allocate them as well. I can just traverse across them. And I find this so much easier to write and to comprehend. Again, I use tagged unions throughout my code. Like a lot of the compiler works on knowing, hey, I know what the max amount of these things are going to be in there, so I'm going to allocate them. And then, hey, actually, I can just keep allocating. So give me the next slot, then the next slot, the next slot. That's how my parser works. That's how my type checker works. It's even how my most parts of the compiler work. There's only 1 or 2 bits that don't work that way, like the non-deterministic things, like the hash tables and such. But yeah, that works. But the thing is, you can use both together. So this is some code from my actual compiler for a tagged union. And this is a transliteration from C to C++-ish to my language, Odin, I'm calling it at the moment. So here's all the types that you don't have to worry about at the moment. So this is the bit thing here. So here's an entity. Entities are kind of objects in the code. So a structure and a type, values, procedures, whatever. These are all different entities within my code. There's also built-ins as well, because they're special procedures usually. I may change the code there, but whatever. And this is kind of what it looks like. I've got some base information for it, like every entity has. Like has a GUID, has the kind, the tag, GUID type, has a scope, the token, and the actual underlying type of that entity. So if it's a variable, it could be an int, could be a procedure, whatever. That's underlying type. Then I have the tagged union information. Here's the union information, and I have to write this all out. And this is kind of looks all right. It's not that bad. It's a small example, but it gets quite hard to manage, and it's unsafe, and it's not usually useful. This is kind of how it works. The using stuff I need to merge into variable because it's only a hack, but I'll fix. Again, but the thing is, this does not include any of the constructors for the procedures to go along with them, so it's a nightmare. Just to prove that, we'll actually go to the entity thing for you. So here it is, the name of the thing. So I've got the enums and the strings for it. Here's the types. Here's the actual union for you. Here's the GUID. Next thing, get the new GUID counter. Here's to allocate the entity, because I'm doing it, if you want to do it by thing. The allocator will be just a stack allocator in this case. Here's make the variable type, make the using, make the constant, make the type name, parameter, field, procedure, built-in, dummy variable. So I've had to create all these here, and it's like, why? Why do I have to do that? So we could still have that version, but we can have it a bit nicer. So I'm going to say, hey, we're going to use a tagged union thing. The base information is going to be in here. And then we're going to just keep using the base information on each of these types. So this is the tagged union code as well, and it's already a little bit nicer and easy to manage. And the thing is, I didn't have to create any of these constructors anymore, because I can just say, give me the variable, set the base that you used, and it's anonymous, whatever. I just had to call it like any other type. I didn't have to create a constructor, because all I had to do was call the type and do the type literal. Now, again, I'm using the inheritance style, so everything's still got this base class to it, but I'm also using the entity kind of structure as well. So it's kind of, it has both advantages to it. So that's kind of how I like it. So again, other things in my code that work that way with type unions, again, you've seen the parser that works that way as well, and that's just that's not the constructing code. So then here's all there's the one thing, actually you do need that for most things. Then you have everything. Here's all the constructors for all the nodes. Let's just keep going through them. I shouldn't have to write these. It's annoying. So yeah, there's a lot going on. Still going, by the way. There we go, ended. So the size of an entity is the size of whatever the biggest value is in there. That's all it is. So each entity is the same size. Unlike an inheritance model where an entity is whatever size it could be. So it does use up a bit more space than the inheritance model. That is true. But technically I say the inheritance model is, yeah, you don't know what size they take up. You don't know what things you could do. You could say, yes, you could have them allocated to one big array, so all the constants in one thing, all the variables in another, all the type names in the other. That's fine. But in my opinion, I prefer to do it this way. I know the exact size of everything I'm ever going to be allocating. Like, I know I'm ever going to have like 1,000 entities, so let's pre-allocate them. But I don't know what types they could ever be, so that's fine. With the other one, it's like, okay, how much memory do I need to be? Like, oh, what's the biggest size of the base class? What's this? Like, it's harder to do. So that's kind of the problem. But again, so we've got tag unions. That's great. So you may be thinking, so why would I even want raw unions anymore? Like, why is there a use for raw unions? And the short answer is yes, there still is. And I use these quite a lot in my math libraries and stuff. So it's especially for mathematical types. So I say I've got vector 2 here. And I'm using an X thing structure here. We've got X and Y. I've also got it expressible as an array and expressible as a vector. So this is SIMD vector, SIMD-ish vector, I should say. Got another vector 3 here. So I've got X, Y, and Z. X, Y, so it could be a vector 2 base thing, or an entity, an array, or a vector. My other thing is here, I'm not sure. So I'm going back. Yeah, I shouldn't need to be repeating all the bases and stuff, but you could get around that by just embedding the union in another structure, like I do in C. But I don't know, whatever. So that's kind of what it is. And look, you can still access. It's going back to the raw unions. So I'm jumping over there, and you can notice that look, you've got .x, .e. You can do whatever .v, and it's very useful to do. And I can access in different ways. Like sometimes I want to access a vector as the elements itself, like a .x, or I want to access them as an array, so I can just traverse across them, or again a vector if I just want to add them together as a big thing. So it's kind of like that. So that's the end of the demo at the moment. There's quite a lot actually. How long has this been going on for? Like 40 minutes-ish, 30 minutes, whatever. And so, oh hello Zach anyway. Just some people. So that's great. That's kind of like what it is, and that's kind of all I've got to show for today. There are other things, but they're not finished yet, so I'm not showcasing them. So I think I'll just have a break to drink, and let's get to the question and answers if anyone's got any. So I'll be right back. We need to go to. Need to write it. Oops. Q and A. There we go. Yes, Q works in here, yes. So, well, I notice it anyway, I can just read it. So, first thing is, are you going to have both inheritance model and the union? So yeah, I've got the subtype and the union. They're both keeping them there because they've both got different advantages. They're kind of virtually orthogonal concepts. So you can use them you can use them both together to achieve stuff you wouldn't be able to achieve on their own. Can you match with enums? Yeah, of course you can. So let's just, you can see a match statement here. You can go like, where's a good example to use it? Whatever. Looks good. So that's fine. Okay, this Mikhail's asking, delete, min, max, absolute are all overloaded. Why can't you make your own overload procedures then? Also, why not overload new, so new type and then new type, len and cap? Okay, so that was what he said. And the main reason is, actually these are kind of weird. Delete I might remove. I even added a question here. Should I just call it free and have like free slice? I'm thinking that's a little bit... probably it is probably right. You shouldn't really need to overload it, and I probably don't even need the keyword delete when I have like free or dealloc or whatever. The thing is about min, max, and absolute is they are kind of absolute overloaded, but they're not. They're actually on a compiler level. They're not in. They're a built-in thing again. It's not in a kind of level and thing. Well, I'm trying to think of the words now. Yeah, it's not in. It's not something you can write on level, because I don't have function overloading yet, or operator overloading or anything like that. I don't think I ever want operator overloading as a short answer. And function overloading, or procedure overloading, whatever you want to call it, I'm not even sure if you need it, because, just hear me out, one of the big uses for it is like ad hoc polymorphism. So you've got like an add function, and you can change the types, like, but it's a bit like... Do you really need it? Yeah, it's a bit of a convenience. But if I've got namespaces and I can nest procedures and such, then it's a bit easier. You can think locally about a problem. Again, function overloading is useful in some cases, but then it's a bit confusing in others. Like, there may be things that have very slightly different arguments, but it does completely wildly different things. It's a bit, ugh. But yeah, so that's why. And also new and slice. I kind of want to be explicit. Is the short answer. So I think I'm going to need to get rid of the overloading on these allocation things. What's going on? Variables have no types. Can you specify them for expressions? Variables all have types. Every variable has a type. All I'm saying is these are inferred. So a in this case is an int. This would be a slice, so it's that. And that would be a slice. So everything has a type. There is no kind of void in this language. Everything has a type. In one sense, if that makes any sense. Yeah, the entity stuff is probably a lot simpler doing that. I was trying to show an example that you can use both together and it works like that. So, whatever. Like, okay, on using a namespace, that's probably an alright idea, but I think... I don't know, it's kind of like, it's probably a weird concept to think about, like, can you strip out this stuff in this namespace? It's just a bit, I don't know if that's a good idea or not. And again, the using idea is kind of nicked from JI, which is also nicked from Pascal, which is with. I'm not sure if I should change it from using to with, because I don't know. It's a bit weird. Why did I get rid of semicolons? Main reason behind getting rid of semicolons was consistency. I actually don't mind semicolons at all. It's not because I don't mind typing them. It's because I was setting rules where I didn't want to type them in certain places. Like, I didn't want to type them at the end of a procedure. Like, I didn't want to have to type it here to be consistent. I didn't want to have to type it after, like, structured definitions or anything like that. It was just getting a little bit annoying. Like, I didn't want to have to write semicolon there. But so I said, look, I had a rule in saying, hey, this doesn't work. Okay, so what's this? I would like to have at least pointer indexing. I don't think it is that useful, to be honest with you, and I'll explain why. Let's just go to the runtime stuff. So this is what I do to use pointer indexing, and it's quite useful usually. I just turn that pointer into a slice, and then I can do it all. It works. So I just slice a point. This is mem copy compare. It's a very bad mem compare. You just get some, compare them, class them to be bytes, and then set a length to them, so then I can just compare the memory as if it was just bytes. And you don't need... That's kind of the thing. I don't want... It's this kind of weird thing, like, pointers are weird. And I don't think having explicit pointer arithmetic is actually needed. Like, it's also probably problematic as well. Like, there's places where I really need them. Actually, let's go to the old runtime. Right, this is when I was doing my own mem copy, and you can see I was doing pointer offset everywhere just to get this working, but it works. But it's not that problematic. It still works. But yeah, I don't really mind that. How does your compiler work in 0.2 seconds? It's actually faster than 0.2 seconds. So let's just go to the build. Let's go into debug mode and compile it as we go along. Okay? So let's go to here, here, here. Let's go to main, and then let's add the timing information to show what's going on. So this is one thing I was working on the other day to get it really, really fast. And let's go to the demo as well and get rid of the stuff like that. I don't need that printing out. Why is that double printing? I know why that's double printing. I'm a numpty. It's running it twice. That's why I didn't comment that out. So, what I show here is the parsing takes 6 milliseconds, the semantic checker takes 10, the generation of the SSA tree takes 5, that printing of it, actually generating the code, which is that. This is the LLVM code, it's like high-level assembly language, takes 8 milliseconds. The optimization part takes 46 milliseconds, and the Clang compiler part takes 64 milliseconds, weirdly enough. So, what I'm doing is, I'm not outputting to C or C++, because that usually takes long to compile. I'm outputting to LLVM's intermediate representation, which is this, which is like a high-level assembly language. And then that gets optimized into bitcode for LLVM, which then the compiler takes into account. I'm using Clang as the bitcode compiler and the linker. Now, I was experimenting with many things here to get it down. Like, why is Clang, it used to take like a lot of the time, it used to take over like 80% of the compilation time. But then I was like tweaking things in the optimization bit, the LLVM opt bit, which turns this into bitcode, which is demo.b. This is bitcode. And I noticed that if I put on certain tags, it turns it into made Clang faster. And I was like, what the heck? How's that working? Wait, and this is all because like SSA, which is single static assignment, is great for optimizers. Is the short thing. Like so if you can figure out, like, hey, I need to optimize this, whatever, it does it really, really fast. And that's kind of how it works. So this is how it's kind of got it fast. I was working yesterday to actually make it even faster. So I actually, instead of printing each new thing to the file every single time, like with fprintf, I store it into a buffer, and then when that buffer gets full, I print that all out and then do it again. So it used to be 70 milliseconds. It used to take the IR part. Now it takes 8, so it's a tenth of the time. Okay. So, okay. Any other questions at the moment? Yes, I probably miss using semicolons as well, Zach. I know, it's just, I don't have to worry about them now. I don't want to add it. I could add it, but it's like, the reason why I got rid of it is because if I'm dereferencing structs every time, for pointer indexing, I should be able to dereference automatically for arrays. And again, this is so I can refactor code. Like, I may say, hey, actually, I want to pass this thing by pointer rather than a value, and I don't want to have to rechange a lot of the code. It would just work like that. So the other thing is, on tagging, why no implicit using on all base things, not having to put them in a struct and do, why not have to write, again, that's one of the questions I asked, and I'm thinking about doing that. But the other thing is, reasoning is, I don't know, it's, I want the thing of the least surprises again. It's that kind of that thing going on. Like, what's the least surprise? And it may be a better idea to do, like, this would get repetitive after a while. So yeah, I don't know. So I'd have to think about it. And I think probably wrapping in a struct is a better idea in the long run. So yeah. Yeah, I think wrapping in a struct's a lot better, actually. I have an idea. But well. So any more questions on my reading? Just let me just check quickly. Like that. Any other like ideas that make it? And again, I know I've nicked a lot from JI. I know that. But I don't know. It's just, there's some ideas when you think about it and you think, is that actually a good idea? And I want kind of like people to kind of like challenge me and say, that's actually a crap idea, Bill. Or it's like, you could do it a better way. Or why do you need that? Like, I don't know. So it's quite good. I'm quite happy with it. Again, the using stuff wasn't actually that difficult to implement, weirdly enough. But yeah. How would I describe Odin in a few words? Bill's language what he made when he was drunk. One stream. No, actually, no. It's probably a better way to explaining it is I don't know. Could you do a block defer? Yeah, of course you can. You can defer any statement, and I mean any statement. So except declarations you can't do, but you can defer a statement. So where's find defer here? So if you wanted to do this into a block, you mean like do that? Yeah, of course you can. And in fact, you can do a defer in a defer if you want, or let's go tortoises all the way down, like whatever. You go scope, so blocks will work. One of the great things I like to do is sometimes if you want to do hiring, like defer if is also a good construct to have. So like defer if this doesn't equal null, and then you can delete it. So that's another thing you could have. So another thing that someone asked was, why don't you just do it in the same line? And the thing is, you kind of can. You can just do that. Like, you could do that. I know it's a bit verbose, but it's very explicit. I like being explicit about things. Defer means defer this statement until the end of a scope. And it stacks, it's like whatever first in will be last out. So to prove what defer is, if you don't know what defer is, again, I did this in the last demo, which will be on YouTube, and you're going to watch that. But to give a short brief thing of what defer does, is if I have a scope here, now I write defer print string, and I write A, and then I write print string B. I just put a new line on everything first. What you'll notice is that B gets called first and then A afterwards because it gets deferred to the end of the scope. It's a scope exit like in D. But if I defer both of them, B gets called first, then A, because A gets put onto the stack first, then B, and then it calls on reverse order, like you put, like if you're doing stack variables, that B gets called on, then A. That's what defer is, and I think it's a superior way to a RAI, in my opinion, like resource acquisition is initialization or whatever it is in C++. And it's explicit. I like being explicit about things. I'm trying to make a better C is the short answer, not a better C++. And that's kind of the idea. So that's what defer is. So it's a way of structuring a program. Like here's the initialization, there's the deletion, whatever. You can use it for like closing of a file or whatever, or open a mutex, then defer the closing of the mutex, whatever. That's all that works. And that's kind of what it is. There's many of the features in this language that are a bit weird to many people. But that is what defer is. And it's a very simple thing to think about. And it's very versatile as well. I don't think there's many languages that can do what this is. It's kind of that. When will I stream again? Whenever the next demo is probably, or when I'm implementing stuff. I have no real time frame. I don't really plan this, except not really. Whenever I feel like it and whenever I can as well. Is that it? And should I end the stream now? Yeah, so thank you all for watching. If you've got any questions or suggestions, I don't really want syntax ideas, but if you've got any questions, please send to this email address. If you've got any suggestions or really good ideas about programming languages or stuff, please email me at that address. This isn't a mailing list or anything. It's actually an email address. It's language@gingerbill.org. That's it. That's the email. So thank you all for watching and coming along to this stream. I hope it was enjoyable, and hopefully I was making a lot of sense. Or not a lot of sense, but I don't know, whichever way. So thank you, and goodbye.